All right, hi everybody. Here is the quiz on Unit 4. The quiz is not this long, but it has these same types of problems: simplifying, verifying, double and half angle formulas, and sum and difference also formulas. So for this first one, when you're asked to reduce, the idea is that you don't have your answer as a fraction, and the goal is to try to get it to a single word. Now, it's not always possible to get it to a single word. You might have sine minus cosine, or you might have tangent times cosine. So you might have two things that don't simplify any further. So the idea is use the identities. We don't have anything squared, and we don't have like 2 theta or anything like that. So we don't have any identities in this one. So I'm putting everything in cosine and sine. Please make sure you pay attention to the fact that there are 2 fractions here. I'm going to put my sine over 1, and tangent, of course, is sine over cosine. You cannot cross off these cosines. They are not from the same fraction. This is essentially one term, and then this is the other term. In order to add these 2 terms together, you must have a common denominator. Currently, the only denominator is cosine, so that means this first fraction is going to have to be multiplied by the top and the bottom by cosine. So now we have a common denominator. So the common denominator is cosine x, and you can see first 2, cosine times cosine. This is cosine squared x, and the second group, sine times sine, plus sine squared x. Sine squared plus cosine squared is 1, and essentially the problem is finished right there, but you're not allowed to have a fraction, so you got to flip it over, or not flip it over, but give its equivalence. 1 over cosine is the same thing as secant. For number 2, this one's a little trickier. I'm going to take a look at, before I do anything with this right here, that sine squared, I'm just going to simplify or see what happens with this sine theta cotangent, which is cosine over sine, and then that's going to be 1 over cosine. I just want to see what's going to happen with this. Maybe I want to keep it sine squared, because if I end up with a sine, then you want to keep sine squared. It looks like, though, all the word sine is gone, so we don't want to keep that squared either. We're going to have to get rid of that. And so let's take care of that at this point. 1 minus sine squared, all of this, 1 minus sine squared, this whole thing, is cosine squared. Now I know this fraction's kind of junked up, but this is a minus sign. And it looks like on the top it's cosine over 1 over 1 over cosine. Oh, and it's theta. If you switch back from x or theta, that's up to you. That's fine. When we simplify this complex fraction, it looks like we get cosine squared, that's this one, and minus cosine squared from the fraction, and cosine squared minus cosine squared is, of course, 0. Now, the verifying problems are basically the same as what we just did, except now we have a goal. Now you know what the answer is, so you'll know very clearly what to aim for, and you also know when to stop. Subtracting fractions, I'm going to go with that side. Common denominator means we're going to have one of each thing. Those are not the same. We have 1 plus cosine times 1 minus cosine. So this first fraction is missing 1 minus cosine times 1. That'll be easy. And this fraction is missing 1 plus cosine. We multiply that by. We got to be careful because there's a minus sign right here. So we're going to distribute that negative sign. Be careful with the minus signs. So this first part is 1 minus cosine x. Now we distribute the negative. Negative times 1 is a negative 1, and negative times a negative cosine is plus cosine x. Oh, sorry, this was a plus. This is a minus. Sorry, I couldn't see it. I was like, wait a minute, something's happening. So that was always a plus, and we just multiply by a minus. So now the 1s are gone. We get negative 2 cosine theta. It's not squared. I almost made it squared. It's not squared. There's no formula for this. It's just a negative 2 times plain old cosine theta. on the bottom, this is the difference of two squares, and very easy to multiply. You get 1 minus cosine squared. And I guess it's been x this whole time, sorry. 1 minus cosine squared is sine squared. So now we have minus 2 cosine x over sine squared. Well, sine squared is negative, this is the numerator. Sine squared is like saying sine times sine. Look at your answer. This is where cotangent comes from. 1 over sine is cosecant. That's exactly what we're trying to get to. So we essentially have negative 2 cosecant cotangent. So we have exactly what we're supposed to get. For problem number 4, I think the right-hand side looks a little bit more complicated. We have nothing squared, so no identities can be used. This is a little bit rough. The tangent is sine over cosine. And of course, you know you can't add that together unless you have a common denominator. You can't just make it 1 plus sine. You can't make it 1 plus sine over 1 plus cosine. You can't do any of that. This 1 we're going to have to turn into cosine over cosine, because that is the common denominator. This is still the bottom of the fraction. Sine x plus cosine x. Can't do much with that. This is the numerator. That's where the plus sign is going to go. Cosine x plus sine x. The denominator, it is a single denominator. It is not squared. I'm going to put this over 1, so now we can do this. So on the top part, that's our top. Cosine x plus sine x. And the bottom is cosine x, don't multiply, times the quantity of sine x plus cosine x. You can cancel the quantities because, first of all, you are multiplying. And now we have 1 over cosine, which turns into secant, which is, of course, as you can see, the answer. Now, for number 5, it says, very specifically, you have to use the sum or difference. It's forcing you to use those formulas at the top of your little half formula sheet there. So we have to come up with a way to get 15 degrees by adding or subtracting two angles. And remember, my trick is if it ends in a 5, use 45. So I'm going to use, in order to get to the 15, I'm going to use 45 minus 30. The order is very important, otherwise, because you don't want it to be negative. I'm going to write this out with the formula. It goes sine A. Now this, your first angle is your alpha, your second angle is your beta. So it's first, second, A, B, first, second, all the time. So sine of 45 times the cosine of 30. In the sine formula, if it's minus, you end up subtracting. The signs are the same. And then we would have cosine 45, sine 30. Now get rid of the words. What is the sine of 45? Well, it is radical 2 over 2. Exact value means no decimals. And then we're going to multiply that by radical 3 over 2 minus cosine of 45. Again, when you do this, the word is gone. It's radical 2 over 2, and the sine of 30 is 1/2. Multiply straight across the top. You can multiply anything, numbers times letters, radicals times radicals. So we get radical 6 across the bottom, that's a 4. Radical 2, of course, that's on the bottom, again another 4. Single fraction, square root of 6 minus the square root of 2 all over 4. Generally, when you have to use the double angle formulas, I'm just looking right at the question, not really thinking too much about it. This generally, when you see the double angle, it usually means you're going to have to draw the triangle. In fact, if you read the question, it tells you it terminates in quadrant 4. That's also another hint that you're going to have to draw the triangle. So there's our quadrant 4. Cosine is, of course, adjacent over hypotenuse. Here's your angle. Adjacent to the angle, hypotenuse. Use Pythagorean theorem to find the missing side. 4 squared plus x squared equals 5 squared. So 16, if you already know it, great. Here we get 9, square root of 9 is 3. So to use the tangent of 2 theta, it's 2 I'm going to put that over 1 times the tangent. All scholars take calculus. The tangent's negative here, and the tangent is negative 3/4. The bottom is 1 minus that same number squared, so negative 3/4 squared. Across the top, when you multiply, that's not subtracting, is multiply. You get negative 6 over 4. And then the bottom, you can put in the calculator, however you want to do it. You get 7 over 16. Then you can put that entire fraction into the calculator. Make sure you make the calculator tell you the fraction at the end. It's negative 24/7. No decimals. Again, I see cosine of 2 theta, so probably we're going to have to draw the triangle. And you can see where it's telling you you're between 180 and 270. So that's quadrant 3. It says the cotangent. Well, the tangent is opposite over adjacent. So this is adjacent over opposite. You've got to use Pythagorean theorem to find the missing side. 4 squared, or 2 squared rather, plus 3 squared, which is 9, equals x squared, so it's 13. And then we take the square root of that. So square root of 13. Doesn't simplify, so we'll leave it like that. I am going to use the cosine squared minus the sine squared formula. Because of that radical 13, I think it's the easiest one. So the cosine is negative here. So we have negative 3 over radical 13 squared minus, sine is also negative, negative 2 over radical 13 squared. Now your calculator is not really going to be helpful on this step. Square the top, you get 9. Square the bottom, plain old 13. That minus is there. Square the top, square this negative 2, that's a 4. Square the radical 13. And then when you do this with fractions, you can put this in the calculator now, or you can do it yourself. Common denominator stays the way it is, 9 minus 4. 5 over 13. Now this is half angle identity. So we want to do pi over 8. This is 22.5 in degrees. So that is 45 divided by 2. So when you use a half angle identity, the first thing is take your angle and multiply it by 2. So we're really doing 22.5. And that's 45 divided by 2. So now we're going to have, this is first quadrant, so this plus or minus out here we don't need because we know it's positive. 22.5 is little angle, first quadrant. 1 minus cosine of 45. That whole thing is over 2. We'll get rid of the word, put in what the cosine of 45 is, which is radical 2 over 2. That's on top of 2. That's a plain 2, but remember, this radical sign is there. So this 1 we turn into 2 over 2. So there's a radical sign over all 4 parts of this fraction. So here's that giant radical sign underneath there, 2 minus radical 2. Right here, I'm right here. There's a radical sign underneath that, make it a common denominator. There's still a radical sign over this one, and there's a radical sign over the 1. Now you go top and bottom. So we get the square root of 2 minus radical 2. Radical 2 times a plane 2, or radical 2 times another radical 2 is a plane 2. All right, now the solving. Look for a number like a 3 or 4 in front of your angle, and those are the kind of the newer ones. Those are the kind where you have to fix that by multiplying your interval by the number. This first problem, we don't have that, but the bigger issue for the first problem is that they're in 2 different words. 2 different words. Let's try to see if we can cross multiply this. Let's see what happens. So we have radical 2. I'll put that over 1. Make this all one fraction. Tangent is sine over cosine. And then here we get 2 sine x over 1. I don't know what's going to happen with this. Let's just cross multiply and see. So we have radical 2 sine x equals, now we go this direction, 2 sine x cosine x. Didn't really help us. I'm going to put the 2's together. How's that going to work? I'll try something else. Oops. So all that did was cross multiplying, just put us right back to where we started. So I have a different idea. Let's just start by dividing both sides by 2. So now we have radical 2 over 2 tangent equals sine. The goal is to have number equals word. I'm going to divide by the word, but I'm not going to get rid of it. I'm not going to cross it off. You can divide by the word if you keep the word. If you divide by word and start crossing the word off, that's not going to work. So radical 2 over 2. So now I have sine x over 1 over sine x over cosine x. Radical 2 over 2 is equal to sine x cosine x over sine x. And so right there, all of a sudden the problem got a lot easier. We just have radical 2 over 2 equals cosine x. So what angle has a cosine of radical 2 over 2? The directions tell us we're in radians. Cosine is positive at pi over 4, first quadrant and fourth quadrant, 7 pi over 4. This one is in degrees. I see cosine squared. We're going to probably have to change that. But let's take a look at cosine times tangent first before we do anything, make any other decisions. So cosine times sine over cosine. Yeah, the cosines are gone, so we definitely do not want the cosine squared. So that's going to have to come out. We're going to put in its spot 1 minus sine squared. And then, of course, equals -1 still. This has a -2, so we're going to distribute that. Don't forget about the sine of x first. -2, that's plain, plus sine squared x. And I'm going to bring this one over, plus 1 equals 0. Put this in a better order so it could be factored. Sine squared x plus sine x, and then -2 plus 1. In order to get sine squared, it's sine x times sine x. In order to get to 1, it's 1 times 1. Oh, I forgot my 2 sine squared. Shoot. That's no good. Sorry. You probably already knew that. I put an arrow, but then I never drew it. I fixed the sign, but I left the 2 off. So we're going to have 2 sine x times sine x. So outside this is a positive 2. And inside is a 1, so we want it to be positive 2 minus 1. So the sine of x is equal to 1/2, and the sine of x is equal to -1. Now you can use your calculator if you get stuck, if you can't remember the unit circle, but it only gives you one answer. Like for this one, it only gives you 30. You're going to have to remember all scholars, and then this is also going to be 150. Where does the sine equal -1? Only one spot, 270 degrees. Now your calculator will tell you -90 there, but according to the directions, you can't have negative numbers, so you got to fix it so that it's not a negative angle. Give the coterminal angle for it. All right, so here's one of the newer kinds where we have a 3 in front of this number. So in order to get rid of that 3, you take and distribute the 3, which is weird. You're going to multiply the beginning of the interval and the end of the interval by that 3. So we're 0 to 1080, or 3 complete spins. Now it's not tangent of 3x anymore. We just got rid of it. So tangent of x equals 1. So what angle or angles have a tangent of 1? Tangent is positive in 2 spots, quadrants 1 and 3. So that's 45 degrees and 225. Well, now you got to add 360 to both of those. 405, 225 plus 360, 585. We got to go around one more time. 405 plus 360, 765. And the 585 plus 360 is 945 degrees. Well, the directions, we still have to follow them. We're only allowed to go to 360. So now we're going to go back and divide every single of these numbers by 3. Don't leave them like that because there's answers. So this should be 15 degrees, 75, 135, 195, 255 degrees, and 315 degrees. And now all of them fit within 0 to 360. Now for this last problem, Again, we have a 2x. Now, we have a formula for 2x. However, this one is sine squared. There is no squared for the 2x. So because it's sine squared, we're going to solve this one just like the one we just did. So we start by multiplying the beginning and the end of the interval by 2. So we're 0 to 720 degrees. So now we have 4 sine squared. The 2 is gone. Equals 1. So divide by 4. Sine squared is equal to 1/4. Oops, sine squared. And take the square root. So we get that the sine of x is equal to positive and negative 1/2. Well, that's all 4 quadrants, but we only have to go twice around. So this is 30, 150, 210, and 330. Then you add 360 to each one of those. So 390 degrees, 510 degrees, 570 degrees, and 690 degrees. Then you have to go back and divide each one of these by 2. Please don't leave it like this. I just did that to show you what we're dividing by. And the answers are 15 degrees, 75 degrees, oops, 105 degrees, 165 degrees, 195, 255, 285, and 345 degrees.